Hey, welcome to day number 6. And I tried to warn you guys that the last half of this chapter is a little bit of a switch up. Check this out: scatter plots and trend lines. So we're switching gears. We were talking about absolute values. Now we're getting into scatter plots and trend lines. Now, hopefully, you have seen scatter plots before, and you may have seen a trend line, but we're going to be able to use scatter plots to display data and identify a line of best fit that we can use to make predictions on the future of that data, what we can maybe see in the future based off how things are going. And so, speaking of scatter plots, hopefully everyone watching has dealt with scatter plots before. A scatter plot is just a graph. Okay, it's a graph that relates two different sets of data, maybe time and population. So examples could be like the one I just used: time and population. Those are two different sets of data. By displaying them as, check it out, ordered pairs. So, hey, we dealt with ordered pairs a ton last chapter, and even some this chapter. We know an ordered pair is where you have two coordinates put together, an x and a y. And so check this out. Check out what a scatter plot, if you don't remember. You could try drawing one yourself if you want to pause the video and try it. But we know that this is our y, or this is our x-axis. This is our y-axis. And the scatter plot is when you have a bunch of points that have x's and y's, of course, and yeah, forms like a little bit of a pattern almost. You can see that here. And so how would you guys describe this right here? Well, we would probably say that has a positive trending relationship, right? All these points are kind of trending upward. You can maybe say positive. So a way we describe the relationship is we use the word, check this out, we use the word correlation. We say, hey, how are these points correlated together, right? It's a way of describing the relationship. So you guys would definitely say here, this probably has a positive relationship. I bet you guys would agree with me there. So we would say a positive correlation. And so what I want you guys to do, if you don't care to mark these out for me, I want to reverse, not all of them, let's just reverse, actually, yeah. I want to do it this way. Let's put negative over here. We got negative correlation. Let's put no correlation in the middle. And then let's put positive correlation there. I like this better because, think of the number line, negative to positive. And so, guys, when we talk about correlation, the letter we use is the letter R. I guess because there's two of them in there. Correlation, we use the letter R. And so we're saying, is R going to be negative? Is R going to be no? Or is R going to be positive? Well, here's the scale this goes along. So we said we've got R, right? So when we talk about correlation, it is a scale. We're talking about R. A scale from -1 to 1. So when we talk about correlation, guys, we're talking about a scale from -1 to 1. So check it out. Negative correlations, they deal with the number -1 or any negative number approaching -1, and it's a sliding scale. You get closer and closer to no correlation. What number do you guys think that would be in the middle? What number do you think will be between negative and positive? Oh yeah, you guys got it. 0. And so we would say, hey, as you leave no correlation and go to negative, we could say you have maybe a weak R here at -0.25. Maybe, and then over here you've got -0.75. That would be a strong negative correlation. So you see it's like a sliding scale. The closer you get to -1, the stronger the negative correlation. You guys think it's going to be the same going this way? Heck yeah. As you go this way towards positive 1, of course, 0.25, something, a correlation of R like that would be a weak positive correlation. And then once you get over here to, maybe 0.8, that would be a strong correlation, strong positive correlation, a strong R. And so what I want you guys to do, see if you can give me 3 graphs that you think represent these scenarios. Go ahead and see if you can give me these 3 graphs. Go ahead and try it. That represent negative, no, and positive. Let's see if yours look similar to mine. So here's a negative correlation, and you can tell this one's pretty strong. Then you have no correlation, where there's no real positive or negative trend. Dots are just kind of everywhere. This is whenever you try and use two sets of data that have nothing to do with each other. You usually end up with no correlation. And then positive correlation, you see we're trending upward. And so really the last concept that I really want to dig into is going to be a trend line or a line of best fit. And so this is the line that is drawn on a scatter plot that shows the correlation. So for example, our line of best fit might be, looking up here, right there. That might be the line of best fit. It shows the correlation. So we see that this line you see it's a straight line, has to be straight. And you'll see why. It involves a linear equation like what we did back in chapter 3. But we see it represents these dots and is close to as many as possible. It also shows the relationship between the 2 sets of data the most accurately. So let's say the x-axis was time, and let's say, by the way, time almost always is on the x-axis, and then let's say the y-axis was population. How would you guys say this relationship is between time and population? Well, as time increases, population is increasing, so we would say they have a positive relationship. The more time goes by, the bigger the population gets. And so that is a trend line or a line of best fit. Now, these don't work for no correlation. There's no way to put a line anywhere through any of this. So we can't really do that. But then, of course, for maybe a negative correlation, you could do something like that right there. That's actually a really good line of best fit. I'm pretty proud of myself on both of these. So that's kind of what we're talking about there. And so what I'd like you guys to do, I want to give you guys the chance. This table shows the amount of time spent studying by each students and the grades they got. Well, do you remember what I said earlier? What is almost always on our x-axis? Time. So check it out. Study time. These are going to be our x's, and then our grades are going to be our y's. So we can see that these are connected. There's our x, there's our y, x, y, x, y, x, y. And so we are going to make a scatter plot of the data and then talk about what kind of relationship you've got. So I want to give you guys a chance. I want you to try A and B. See what you get on these guys. Go ahead. And so when we're making a scatter plot, we know that if this is our x-axis, this is going to be study time. And of course, here's 0. And then we've got 1, 2, 3, 4. I can already tell I didn't give myself enough room. 5, 6, 7, 8. Move that x over here. And then, of course, along here, we can see that we have nobody who scored below 62. So here's what we do. Anybody remember? To get from 0 up to where we need to start? Some of y'all do. Bust out the squiggle. Yeah, we squiggle up to, let's go 60. And then, of course, we've got 70, 80, 90, and 100. And so we go and make our scatter plot. We say, okay, if we studied 0 hours, that gave us 62. 1 hour was 71. 2 hours was 65. So hey, must not have been a very productive 2 hours. 3 hours, 79. 4 hours, 82. 5 hours, 92. 6 hours, 94. 7 hours, 88. And then 8 hours, we actually do not have. So I don't know why I made an 8th, but I did. So how would you guys describe, we made our scatter plot, what type of relationship do we have here? Does this represent more of a negative towards -1, more of a no correlation, or a positive? I think you guys would probably agree we have a positive relationship here, don't we? It's a positive relationship, a positive correlation. And in fact, if you wanted to, you could do a line of best fit. Check this out. Probably right through there. And what we could do with this line of best fit is we could maybe make a prediction. We could say, okay, at this pace, if somebody did study for 8 hours, they'd probably be making like, maybe 8 hours, they'd be making a 98. That's what we could predict. We can use this to make predictions. So for 8 hours, we could maybe say they'd be making a 98%, as a guess, using our line of best fit. All right. This is the end of video 1, guys. Join me on part 2 here in a second.